Okay, let's see if that's better. At least I see a microphone working now. Okay, sorry for the delay in the stream, but I had to make sure that I had a microphone. All right, so we're going to start. I'm going to start precision measurement today. Hopefully that you can follow along a little later. It's our last unit, and it's not a very long unit, even though there are 5 lessons. They go pretty quick. So we're going to talk about precision today. Now, precision measurement is an area of math that you might encounter in the skilled trades, things like carpentry, welding, anything that requires engineering, anything that requires very, very precise measurements. I mean, things like pharmacy as well, right? We have to be very careful when we measure medication to give to people. So that's another area where you have to make sure your measurements are precise. So our first lesson is talking about the actual word precision and how that enters into the math classroom and what it means for us. So for us now I know you probably have used the word to be precise in your everyday language, and that means to be just very certain of your answers and to be very careful. In our concept here for today, the word precision actually refers to the size of the smallest unit on your measurement tool. So for us, if we talk about precision, it means we're measuring something. The title of this unit is precision measurement. So of course we are measuring something. I'm sure you've measured something with a ruler or a tape measure, probably a scale. So we've all used some type of a measurement, and we're going to just look at a few of the measuring tools for this first unit and talk about what the word precision means. So in summary, precision is the size of the smallest unit on your measurement tool, the smallest visible unit. Another definition is that it's the smallest tick, and that word tick means like the little hash mark on a measuring tool. And we'll see in this first example that we're going to use it has a ruler, a diagram of a ruler. So this lesson will focus on determining precision in 2 ways: finding precision from a picture, or from a given measurement, like just a number, from a picture and from a number. So basically from a picture, as stated here, or from a number. Now the pictures are easier to deal with, in my opinion, because you can visibly see the ticks on the picture. Using it or finding precision from a given number can be a little tougher. So let's see this first one. Finding precision from a picture of a measurement tool. Remember that precision is defined as the smallest tick on a measuring tool. Below are several examples of reading precision off of a measuring tool. Example 1. The precision of any measuring device can be found by using the formula, the measurement divided by the number of ticks. So sometimes you don't really need a formula, but a formula always seems to help students. So actually, whatever measurement is recorded that we can see, I guess the first number that you can see divided by how many ticks there are. So find the precision of the following. All right. So this is a ruler measured in millimeters. So from here to here is the measurement. So this is the measurement we'll talk about. And the measurement itself from here to here is 1. Now this is actually 1 centimeter. Okay. So from here to here, this ruler is measured in centimeters, and each little tick is a millimeter. So the precision is, okay, so the precision equals the measurement itself, so that would be 1 centimeter, divided by how many ticks it takes. So let's see, this is my starting point. So I put my pen on my starting point and I count. When I get to the first tick is 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 divided by 10. Okay. Or, I mean, you could do your division. 1 divided by 10, and you could say, or precision equals 0.1 centimeters. That's it. Here's another ruler. Okay, so what's the precision of this? The measurement is from here to here. Precision equals the measurement, 5 centimeters, divided by, okay, so how many ticks are from here to here? We just have, this is my starting point, 0. I move to my first tick, and I only have 1 tick. So the precision then would be 5 centimeters. Now, some people might not need this little unit, this little math calculation. They might just say, okay, well, the smallest measurement is 5. 5 what? 5 centimeters. The smallest measurement is 1. 1 what? Well, this would be in centimeters, right? Even though the word millimeters is here, it's just because the big centimeters are chunked into little millimeters. Okay, so let's see what the next page holds for us. Another measuring tool is a weight scale that you see in the grocery store. So let's see, let's take a measurement. I like starting at 0 if I can. Okay, let's start from here. I mean, the first number I see is 20, so I'm going to put down 20. Okay, 20 pounds. And how many ticks does it take to get to 20? We don't count the tick we start with, right? So I'm starting at 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I include the last one, the last tick, but not the first one. So divided by 10. So 20 divided by 10, that means the precision is 2 pounds. Now, it doesn't really matter what measurement you use. I could have used 40, but I would have counted and I would have found that I had 20 ticks, right? Okay, a clock, that's also a tool of measuring. It measures time, right? So the measurement is 5 minutes. Okay, so precision equals 5 minutes. That's what the measurement was. Now, this could be regarded as a tick, and this is a tick, right? So from here to here, just 1 tick. We don't count the tick we start with. We count the tick we finish with. So the precision is 5 minutes. Now, precision will have a bigger role to play in the next lesson. Right now, you might think, well, who cares? But you have to be able to talk about the precision of the tool you're using to make sure that you know that you can later talk about things like accuracy and uncertainty. So let's take a look at the other 2 examples. Okay, we have another clock. We just had a clock. Let's see, this clock is a different clock, right? I'm going to do the same thing. From here to here represents 5 minutes. And let's see. I don't count the tick I start with, but I count every other tick after that. 1, 2, 3, 4, 5. There were 5 ticks this time. So here, the precision is 1 minute. You can see this clock is more precise. It's easier to read the precision because of all the little ticks inside. Our previous clock had nothing, just blank space, so it was harder to read. So it seems to be like the rule I think I would take away so far is the smaller the precision, the easier it is to use the tool. Now, a digital watch, this is tough. We're kind of entering into, although this is a picture, we're actually given numbers to work with. So if I look here, the smallest tick that I can see, this would represent the smallest tick. So I would say the precision, the smallest unit shown is seconds, because seconds is smaller than, right? This would indicate the hour. This would indicate the minute. This is seconds. Okay, so I guess the smallest unit is, I would say the precision is just 1 second. We don't have any ticks or any space. So we would say that the precision is a second. Okay. Thermometer. Let's take a look at the thermometer. It's another tool. Okay, I'm going to start at 0 and I'm going to use this measurement, 10. It's 10 degrees Celsius, right? Celsius on the top, divided by. All right, start at 0. Don't include the tick you start with, just include the rest. So 1, 2, divided by 2. So the precision will equal 5 degrees. This is precise to 5 degrees, right? Because each little tick represents 5 degrees. Let's do this. Okay, what measurement is this? I guess half tank. This measurement is half a tank of gas. So 1/2 precision equals divided by, well, how many ticks? 1. So a half divided by 1 just stays a half. So precision is equal to half, and I guess I should include the word half a tank because that's what we're measuring here. That's it for pictures. Okay, if you remember the first page though, it said, you're responsible to give precision given a picture or given a number. So let's take a look at what numbers are. This is similar to the clock question. So there are times when you have a measurement, but you cannot see the measuring tool that was used. In this case, you have to determine an assumed precision from the given measurement. Determine the precision used to arrive at each of the following measurements. Okay, so 17 years. So we're going to talk about place value, right? This is the tens column for place value. This is the ones column. Which one is smaller? Well, the ones column. So how do I measure? This number changes. You could start at 0, it would be 10 years old, and then 11, 12, right? It would go up. So we would say the precision is 1 year. Because that's the smallest tick for years, right? We measure years of growth by 1 year. So this is the tens column. This is the ones column. And this is the tenths column. So precision equals 1/10. 1/10 of a pound. Or if you want, you can do the division, 0.1 of a pound. Here, this is the ones. That's not the smallest. This is the tenths. That's not the smallest. This is the hundredths. So precision equals 1/100th of a second. Now you can leave it like that, or you might want to do this. 1 divided by 100, and I get 0.01. Now you might want to include your lead 0, that's a little more proper. Now when we're given a number to work with, notice that our precision just includes a series of ones or zeros. We don't end up including any of the numbers themselves. We just include the placeholder. So let's do this the quick way. What would this be? 17,569.8. It's got 1 decimal digit, so that's the precision is 1/10, or if it's in the 10th, just if you only have one number past the decimal, your precision is going to be a 0.1. If you have two numbers past the decimal, your 1 moves over. Your 1 is always represented in the rightmost place value holder. Okay. So, for example, let's say I'm going to do one more example. Let's say I had a number 72.3594 centimeters. The precision would be equal to, I just count my number of decimals, 1, 2, 3, 4. That's how many decimals I have to have represented. The 1 goes in the last place, so the 1 will go here, and I fill it up with zeros. And I can include my lead zero if I want. But if your given measurement has 4 decimal digits, your precision will have 4 decimal digits. They will be zeros, and a 1 will be the last placeholder. So that's the quick way to think about precision when you're given just a number. And that's it for precision. And I'm going to leave it at there today. So I'm going to give you, you've got assignment 1 to work on for the weekend, I suppose, or Monday. Monday I'll have as a work class, and then I'll go over some of these. So you've got a series of a few pictures and a few numbers. So that's what I'll leave you with for today. So take care, try and have a nice weekend. It should be nice and warm tomorrow. So hopefully you can get out and enjoy some sun.